guys, welcome to example 2 of 9.4. Before we get to example 2, I'm going to add something to example 1. Over here, I have like a very general expression for the formula, which isn't a formula, it just says a sub k, right? Because that represents the formula. But if I actually want to write the explicit formula, I can just rewrite my answer like this. So it would be a summation from 1 to 9. And over here, I'm going to input in the explicit definition of the sequence, which should be the first term. In this case, it's 8 plus the common difference times k minus 1. And that would be the explicit definition, and this would equal 144. So technically, either answer is acceptable, but this answer just has more detail to it. I write that because in example 2, they do have that in the book, so I just want to make sure you guys understand that a sub k is sort of a general expression of the formula, right? As if the formula didn't exist or we didn't know what it was, but if we know what the formula is, we should just put it in. So in this case, we have a geometric sequence, or series in this case, and our a sub 1 is a 4, and our a sub n is that expression over there. So let's write that down. So a sub 1 is 4, a sub n is 4 times negative 1/3 to the 10th. We would need our n, and we would also need our common ratio. Our common ratio is pretty easy. As you can see, the first number is a 4, and then every subsequent number gets multiplied by negative 1/3. What would our n be? How many terms do we have? Well, you can see that over here it got multiplied by negative 1/3, then again by negative 1/3, and then they give us this nice exponential expression, which means that it got multiplied by negative 1/3 10 times. Well, if you include that the first term is 4, that makes for 11 terms. So that means that my n's 11. I'm not going to make you guys go through another derivation. If you want to look at this one, it's actually, again, not that hard. They use kind of a similar technique, but instead with a common ratio. But we're going to use this formula right over here to find our summation to calculate this series. So let's go ahead and do that. So our summation from k is equal to 1 to 11, and our first number is 4, so this would be 4 times. My common ratio is negative 1/3, and this is raised to the n minus 1. All right, so that's my explicit definition of this geometric sequence. Again, this is from 9.3. And we need to use the formula, so maybe a sub 1, that'd be 4, and then 1 minus r to the n, 1 minus my common ratio, negative 1/3 to the n over, I believe, 1 minus r. All right, oh, and I should be plugging this stuff in, so n is 11, and r is negative 1/3. Okay. So take all of that, you can plug it into your calculator. I'll clear that and do it again. So I'm gonna alpha F1 and get myself a fraction that's a little bit nicer to write with. 4, 1 minus negative 1/3 raised to the 11th. All right, and 1 minus, again, negative 1/3. I believe that's it. And we get approximately 3.4017. 1, 2, 3, 4, 1, 7. And that's your sum of this finite geometric sequence. All right, see you in the next problem.